Today we are going to discuss about the rank correlation. So now you already know how to conduct uh, uh, Pearson product moment correlation in your basics level. You have learned that. Then today we are in the step of rank correlation. Then the special term is in here, uh, the rank. So let's see how to deal with that. Yes, this is the key concept. This section describes the non-parametric method of rank correlation, which use paired data to test for an association between two variables. So we can test the strength and whether there is an association in between two data series or two paired data series. So not. Yes, this is the definition for rank correlation. The rank correlation test is non-parametric test. In the other case, you can say it as a Spearman rank correlation. The previous one is Pearson. This is Spearman. The rank correlation test is a non-parametric test that uses ranks of sample data consisting of matched pairs. It is used to test for an association between two variables. So the null and alternative hypotheses are as follow. For PS, denote the rank correlation coefficient for entire population. So you can say this is the null hypothesis. The mean of that is there is no correlation between two variables. So this is the alternative one. So the mean of that is there is a correlation between two variables. So the null is no correlation. The alternative is against to that there is a correlation. Rank correlation has these advantages. The non-parametric method of rank correlation can be used in a wider variety of circumstances than the parametric method of linear correlation. With rank correlation, we can analyze paired data that are ranked or can be converted to ranks. Rank correlation can be used to detect some relationship that are not linear. So the first step of seeing the correlation in between two variables, we can plot our data series. So if I use my pen, we can use one axis toward the horizontal axis, one axis, one variable, the vertical axis. Suppose that I'm putting y for the vertical axis and x for the horizontal axis. So this is 0. Then we can put our values with respect to these two things. Then you will have the distribution of our data set. So there may be some patterns. Due to the data distributed pattern, you can say whether those are related or not, or what are the relationship of there, and you can say it is linear or non-linear. Likewise, you can say. Then rank correlation you can use to test the not linear relationship also. So this is an advantage in here. A disadvantage also in here. Then what is the disadvantage of rank correlation is its efficiency rating of 0.91. So the efficiency of rating is 0.91. This efficiency rating shows that with all other circumstances being equal, the non-parametric approach of rank correlation required 100 pairs of sample data to achieve the same result as only 91 pairs of sample observed analyzed through parametric methods. Assuming that the strict requirements of the parametric approach are met. So this is the thing. So in parametric, you need only 91 observations to have this result, but here it required to give the results for the 91 observation in parametric, you are required 100 observation in non-parametric. So that difference is there. So we can consider it as a disadvantage of rank correlation. So this is a figure. There are two parts. So you can see this image. Then this is the whole flow chart correlation rank test. So here it describes the red color half. So in next slide you can see this half. So all together you should consider this all to have a good idea. Let's see how do you start it. This is the starting point. The first step is, so I think I no need to remember you these the meaning of these shapes, because under another course I have teach you what mean by these things. So the arrows are here. So that is about the conclusion. That is about the way of our action, flow of our action. So the first step is are the n pairs of data in the form of ranks. So you can question. Then n pairs of data in the form of rank. If it is yes, you can go this way. If it is no, you have to go to this way. If it is no, what you should do, convert the data of the first sample to rank from 1 to n and attend to the same for the second sample. So if they are not ranking in the rank correlation test, we have to convert those into rank. Then we are in this stage. Does either variable have ties among its rank? So then we can say, are there any ties? If it is yes, you can move to this one. If it is no, you can go in this way. Calculate the different D for each pair of ranks by subtracting the low rank from the higher rank. So then we need to find the D. Then how do we find the D if not the difference? We are taking the subtracting from the low rank from the higher rank. So you need to reduce low rank from the higher rank. So in this way, if you say yes, you can go to the Pearson product movement correlation test. Otherwise, we have to go along with this path. Then square each different D values and then find the sum of those square to get D square. Then you need to take the square value of that D column. D column is difference between two pairs. So we are having another column called D. Then you need to take the square value of D. Complete the computation of this step. Then you can add those values into this equation, and finally you will have an answer. Okay, now we are in the second half of our flow chart. We already discussed these first steps. I mean about these two. Okay, let's see. Complete the computation. Yes, we discussed. If the observations are less than 30, less than or equal to 30, what we can do? Yes, if it is not less than or equal to 30, we can go in this way, calculate the critical values of this one, whether this corresponds to significance level. If it is yes, if our observations are less than 30, find the critical value for the R using a table. We can see that table later. Anyway, what is the thing in here? Even though you calculate the correlation value, I think most probably we are using the sample data. So this is about R is about the sample data. So in the I think it is available in the later slides. Normally we use row, or in the Greek table row, for the population correlation. So we need to use population correlation. So we need to use hypothesis to test whether our sampling calculations are valid for the population. Otherwise, we have to go for a correct calculation. So these are the requirements. The sample period data have been randomly selected, unlike the parametric methods of previous sections. There is no requirement that the sample pairs of data have a bivariate normal distribution. There is no requirement of a normal distribution for any population, because we know in parametric we consider the randomness and we consider the normal distribution most probably, but here we can consider distribution-less method. So it's not a must to consider the normal distribution here. Okay, then the notations. R value, rank correlation coefficient for sample period of data. Then rho, rank correlation coefficient for all the population data. N, number of pairs of data. D, difference between ranks for the two values within a pair. Yes, these are the things. Okay, again, we are in the stage of correlation test. Now the test is statistic. After converting the data in each sample to ranks, if there are no tie among ranks for each variable, the exact value of the test statistic can be calculated using this formula. So we can use this formula to the test statistic. So this is about the Pearson formula. Okay, now you have a data set. So you can go for the calculations by using your previous knowledge, which I explained before this slide. You can use. Now you can write down this data set and you can make your calculations. So finally, you will have this answer. In the other case, you can make some hypothesis testings also. And just for that, you can make a conclusion based on these things. Okay, these are the things I needed to explain with you. And the nonlinear pattern. So you can see if we cannot make any straight line along with our dots in our scatter plots, we can say it's a non-normal distribution. So these are the things I needed to discuss with you. I think it's too easy to make calculations about rank correlation text. Okay, this is the end of lecture.